Well, hello everybody. Sunny and nice in Gothenburg. Also here in Luxembourg. It's very sunny and very hot today. So, welcome everybody to another Data Europa Academy webinar. Um, so, as you may know, when you register, we're today tackling marine data. So, the webinar is on charting the currents, the potential of open marine data. So we will explore two use cases today, the marine analyst and a pilot study at the Poland's Help Peninsula from two experts on marine data sets. Um, these samples illustrates how open data from the public sector can be transformed into actionable insights that can support evidence-based decisions on marine policy. As you know, on the European Data Portal, we advocate for opening up datasets from the public sector to create innovative data services and also improve, of course, of way of living and creating this data ecosystem. So with these two use cases today, we will show you how important it is to make data free, open, and reusable in an harmonized manner to drive innovation, and in this case specifically to boost the blue economy. Um, at the European Commission, there are several flagship EU-funded initiatives that play a key role on contributing the EU mission to restore our ocean and waters. And we're going to hear more about that later in the presentations. Some of them are, for example, the EMONET project, the European Marine Observation and Data Network, the Copernicus Marine Services, that are the EU observation program to monitor the marine environment, and also the EU Digital Twin Ocean, which is a digital model to simulate the ocean and test scenarios. So we will deep dive into this topic today, and through the presentation, the speakers will address, will highlight how this dataset had been used in order to create such pilots. So first of all, you know that we have some rules of the game to ensure that this session is as smooth as possible. So this webinar, as you know, it will be recorded and it will be published on the Data Europa Academy as one of the lessons. And after the webinar takes place, we will share with you the slides and also the recording. It will take maybe 1 week or so, so bear with us. We're preparing the content for you. For questions, please use the Click Meeting chat where you already saying good morning from the country of, and city of origin, because we will have a Q&A session at the end of the two presentations and we will address them all. And third, but very important as well, we also take into consideration your feedback. So please reserve 3 minutes after the webinar to help us improve by filling the feedback form. So this is the agenda of today. We will have first the presentation from Pascal on Marine Analyst, on the Marine Analyst tool, and then we will go into the digital twinning on the Southern Baltic Sea by Alexandra. So this webinar would not be possible without the excellent experts we have here, very knowledgeable on the topic. So in the room we have Pascal Derike. He holds a PhD in physics and he has a broad experience in IT, GIS, and data management. He worked at the European Commission Joint Research Center and he contributed to the Open Data Catalog. But he also contributed to the Marine Strategy Framework Directive while supporting um, while working on Digimare. He also supported the EMONET initiative that I just mentioned before and the European Atlas of Seas. And now he's the developer of Marine Analyst EU, which is the tool he's going to talk to us about. Currently, he is a data engineer and innovation manager at Cienzano, which is a public institute of the Belgian ministry, contributing to the European health data space for the secondary use of health data. So we have Pascal, and we have also Dr. Alexandra Dukowska. She's a physicist and a coastal oceanographer with a strong focus on applied marine science and engineering. Her work supports practical solutions of offshore wind energy, climate resilience, and sustainable coastal management, often in collaboration with the maritime industry and public authorities. She's going to introduce us the tool of Health Peninsula, and she has experience with academia and the private sector, combining scientific expertise with data-driven approaches to these environmental challenges. She's also an advocate of open research data and co-developer of International Marine Data Literacy course, promoting the use of open data for marine applications. And last but not least is me. You may know me from other Data Europa Academy events. So I will be the moderator of the session, and I'm project manager working for the European Data Portal, managed by the Publications Office of the European Union, part of the European Commission. Having said this, is now the time to give the floor to Pascal and Alexandra. First of all, I would like to thank you so much for accepting our invitation to join us in this day, in this sunny day in Luxembourg at least. So yes, Pascal, the floor is yours. We very much look forward to hear about Marine Analyst EU. Thank you very much.
Thank you. Thank you very much for the Data Academy for the invitation and giving me the opportunity to present the Marine Analyst digital platform. So it's a digital platform facilitating access to open marine data in an innovative way. So the platform has been launched in 2020. It's an open access web platform really designed to simplify the access to marine data. When I say marine data, I think about open marine data, and to facilitate the production of environmental analysis reports. The idea behind the Marine Analyst is to have an intuitive platform, easy to use interface, making it accessible to users and that's important, you don't need to be an IT expert to process data. It serves as a collaborative platform for a wide range of users. So you can have scientists with a good experience of the marine data, but you can have also policy makers wanting to have an insight, or any ONGs, environmental organizations. So it's really meant for the general public. It helps to explore, analyze, and report on marine environmental conditions. So user can visualize a marine data, perform analysis, and generate reports without requiring programming skills. The principles and purpose of this platform is to create open knowledge in the form of reports on marine environmental conditions. So we need open data, we need open source software, and open processing solutions to really make this platform fully operational. I will start with the marine open data. So the Marine Analyst relies on the EU open data policy, and mentioned just before, the platform needs to access data silos like the IMONET, and so, for instance, from IMONET, we can access bathymetry data, or biology data, chemistry data, geology data, also human activities, a theme which is very important, which has a lot very nice open marine data, but there's also physics with salinity, temperature, waves, currents, sea levels. We have also from IMONET seabed habitats where we can have access to marine data about seabed ecosystems. We have also, as a data provider, Marine Copernicus. So usually when we speak about IMONET and Copernicus, or Marine Copernicus, you have in situ data coming really from the ground, from the seas, and you have the Marine Copernicus program with ESA, EUMETSAT, where you've got data from the satellites. Something which is also quite important for the Marine Analyst platform is the access to data. So we rely on standard web services. And here the Inspire directive helps a lot in standardizing the way we access this data. Also important for the marine analyst is this support coming from our the Wikio platform. So it's a cloud computing service designed as data and information access service. It's a project or program supported by the European Commission, and here it's where the marine data is really processed, and that's without this, the marine analyst platform will not be operational. So we need a strong cloud computing service to support the operations of the marine analyst. And I was the around the principles. So I spoke about open marine data and also the open processing. And we rely for the platform also on open source solution. What is special with a marine analyst is that the system is powered by a content management system that enables the management and delivery of computational notebooks containing the analysis associated with the dataset. To give you an idea, we have in the marine analyst catalog around 1,500 datasets displayed in the platform, and we have something like 500 computational notebooks. And the marine analyst has been really designed to do the management of all these computational notebooks, and they are basically R Markdown associated with the datasets. Key features of the marine analyst. So for specific areas of interest in Europe, but also at the global scale, and for instance, the bathymetry with GEPCO, after a dataset request, a document, a report is generated and published on the web. Each report is human readable. So you've got a report in the form of an HTML document, but is also machine actionable. So here it starts to be a bit technical, but each report is semantically annotated with schema.org and also published in a DCAT dataset catalog. A DCAT is the metadata standard promoted by Europe. For instance, the data.europa catalog is based on DCAT AP. It's technical, but it has a huge impact. I will come back to this when I will be at the end of this presentation. But coming back to the user experience with the Marine Analyst platform, when you search for a dataset, you will know if this dataset is available, meaning if there is data in the area that you have selected, and if you can produce a report. So here, the marine analyst embeds powerful tools to help you in finding datasets. So when you have a dataset, for instance, wind farms, they are not everywhere. But if you have selected your region of interest, the marine analyst will be able to tell you there is data available in your selected area. And it will also inform you about the fact that you can produce a report. Each report, they are collected in your personal environment, a dashboard. So that's really a user-centric approach. You can, as a marine expert or someone interested in marine data, generate a bulk of reports using the different open marine data that exist in the platform. Here, it's an example of a visualization page of a marine analyst. You see a mapping tool where you can interact with the map, zoom in, zoom out, and click to see some features. You have also the metadata, and you can do an export, quick export of the marine data for the selected area, or you can process and ask for a report in your dashboard. Another example, so here it's sea surface analysis. You have all the archive of the sea surface temperature available, and you can process it. Here I will go through very quickly one example, but you can understand that from the huge variety of open data that is available from the Marine Analyst platform since 2020. The production of reports is, I don't know, maybe 2,000-3,000 reports have been produced, and they are available, and they are really covering a lot of use cases. So I go here through an example. So it's a report which has been produced for the marine protected area Mer Celtique in France, talus du Golfe de Gascogne. You've got the QR code and you can visit it if you want, but I will go through the report. So it's a report which is mixing data, so vessel density data from IMONET, and also marine protected area, the shape files from the IUCN MPA database, so protected planet. And the report has the following look and feel. So it's basically a report produced by R Markdown script. It presents maps of the selected area, but also statistics. So that's how the marine analyst is producing knowledge. It has also aggregated data in the report. So here you see the different means by vessel types. So, and you can, well, the marine analyst can also embed AI solutions like this example, where we've got hierarchical cluster analysis for this marine data, the vessel traffic. When a report is produced, it is automatically semantically annotated. So according to the semantic web and linked data principles. And you have one associated portal, the fair.knowledge.eu DCAT catalog, which helps you to discover all the available reports which have been produced. And the idea is really to produce these reports as fair data sets. So for instance, if you look for marine data sets, you will find in the web these reports available. So I'm coming to the conclusion. So you see that from open marine data, basically the core principles of the marine analyst is to rely on all these available open data. And here it's basically, I will say, without the EU open data policy, without Inspire directive, we will not have the possibility to develop such a digital platform. But we start from data, we transform the data into information, all these reports, and that's knowledge. No, that's not knowledge, that's the information. But by the fact that we make this for information semantically annotated, we transform the information into knowledge. So basically, we are making the information machine actionable. I go to the next slide, and that's basically my next slide, because what we see since 2 years, since we have GenAI solutions, and they are very popular, is that the marine analyst basically is transforming all the open marine data into knowledge, because these Gen AI agents, they are able to read all the information which is made available through the reports. So for instance, I mentioned for the use case of the vessel traffic that the aggregated data has been computed and is available in these reports. And the Gen AI, they love to read these reports. We see this in the logs of our servers. We have more and more Gen AI robots coming to this data, reading this data. So we have already this idea of reading open data, transforming it into information, and then from the Gen AI perspective, this information becomes knowledge. A comment about these data flows that the marine analyst is supporting. So it's a fair service. We read open data, we transform it into information, but it happens that a data flow disappears. But it's not a problem because we keep all the metadata in place. So all this information will remain, I will say, forever. So we have all these reports, and I will call them fair digital assets, which are machine readable and also machine actionable metadata and data. If you want to know more about the marine analyst, we have a number of nice reviews which has been produced by Wikio, EUMETSAT, or Marine Copernicus that I invite you to read because it was the Marine Analyst launched in 2020 as a nice history which illustrates how we can innovate on data. And I will conclude there with my last slide. I invite you to contact me or to send me a post in the LinkedIn Marine Analyst page. And of course, I invite you to go to the digital portal and to test it by yourself. Thank you very much. Okay.
Thank you very much, Pascal, for such an interesting presentation. Now we go for the second presentation from Alexandra. Please, the floor is yours.
Hello, good morning, everyone. So, thank you, Pascal, for very interesting presentation. It was nice to listen. And now I would like to, because the weather is perfect, kind of perfect, also in Poland. Not very, it doesn't happen very often. So before we begin to discuss more specific topics, I would like to take you to the beach and imagine that we are standing on the beach, and this is the beach of the whole peninsula. And we have sunshine, good weather, and things like that. So Hel Peninsula is one of Poland's most popular tourist destination. It is very unique. It is mix of open sea and shelter bay, and in the same time. This is very narrow, sandy stretch, about 35 kilometers long. In the most narrow point, it's just around 100 meters wide, so quite narrow. But also it is fascinating site from a geological and environmental perspective. It is shaped by dynamic coastal processes and altered all the time by human activity, mostly because of many efforts which are made constantly to protect peninsula against coastal erosion, because it is constantly in danger because of erosion. And now please imagine that storm is coming, and what is feasible now? So nowadays it is feasible to predict this storm, when it so the time when it will occur and what range of wind speed we can expect. So it is like we are in this level of development of our numerical methods, of our models to predict this storm. However, it would be very useful to know exactly what this storm will do to the dunes, the shoreline, even to some operations in ports for our infrastructure. So this is what we don't have, such a tool, and we need it to make such predictions possible. So that's why we need the tool. We call it digital twin, which can give us this information in real time, and it could be living model of the sea, which we can use just for these purposes. So now look at this picture, and we have Apollo 13 mission, and let's think a little bit what this Apollo 13 mission and coastline have in common, why we have these two pictures here. So here is kind of historical analogy, and it started in 1970 from this Apollo 13 NASA mission. It was mission to the moon, and some problems have occurred, and this famous sentence, "Okay, Houston, we had problem here," was from this. It is said that it is from this mission. So something went wrong, and engineers on the Earth wanted to help people in space. Finally, they managed to come back home safely, but during this mission, NASA decided to create a replica of spacecraft on Earth to simulate solutions if some problems occurs, and it was a very early version of a digital twin. So it was not called digital twin those times, but it was foundation of this idea of creating a physical representation of spacecraft in order to simulate behavior in safe environment. So then in 2002, idea of conception of digital twin occurs. It was developed by Dr. Michael Greaves in 2002 at the University of Michigan. The idea was very simple, that a real object, like for example a car, is connected to its virtual copy through data. And this virtual version can be used to test, simulate, improve the real one without even touching this physical object itself. So let's go next. You might be wondering, why is the sea such an important place for this kind of technology? Because now we are thinking about developing this kind of technology for the sea. So sea is a very busy space now. It's not longer just about ships. We building wind farms, running busy ports, trying also to protect nature all at the same time. So a lot of things to manage. And that's why we need this digital twin of environment as well. We have a lot of digital twins for infrastructure, for some like ships. It is for wind farms, so it is in normal use now, but we still don't have the real digital twin of environment, of marine environment. So that's why we want to develop it. Okay, let's go further. So why Hell Peninsula was chosen as a test bed? So it is very dynamic, always changing. We have a very variety of waves, wind, and people shape it every day because of we put a lot of effort to protect it from erosion. So artificial nourishment, other measures of protection this place. So that's why it is really the perfect place to test new tools. And we are testing here measurement systems, models, algorithms, also data sharing tools to build a prototype for the entire region. So we want to use this prototype then in entire Southern Baltic coast. Okay. So what we have here, we have 4 stations in which we have quite a lot of smart, let's say, smart devices to measure what is happening in the sea. So we have these deep water buoys, coastal sensors, current meters to measure sea currents, also weather stations, video cameras, and these devices are located in 4 places, as you can see, and all of them send real-time data back to our system. And we have this digital mirror of what is happening in the real time in the sea. Here you have example of one of this profile. It is in Kuźnica. It is in the middle of Peninsula. So as you can see, maybe on the next slide it would be more visible. We have some shallow water measurements in the real shallow water, like up to 1 meter depth, 2-meter depths, video camera on the beach, weather station on the beach. Then we have about 7-meter depth. It is like intermediate depth for waves. We have measurements of sea currents and wave buoy at about 15 meters. So we consider it as deep water for measuring of waves. So this is like typical profile we have in these 4 places. So how the idea of all of it is that we have this measurement data. These measurement data are sent to numerical models, and we calculate wave currents, sea levels, sediment transport. And this is only beginning because the real essence of all this system is to prepare what-if scenarios which answer questions of our stakeholders. So if we have all these things together joined, we have this digital twin, so virtual replica of this environment we study. And what is very important here, one of the most important thing, is that it couldn't be possible without using external open databases. So that's why we use data from, for example, Copernicus Marine, and without it, it would be very difficult to run all this environment, because what we do to run this system and to develop this system, we need data from atmosphere. Because sea is not, isolated. We have wind, which is the most important factor, and we need the very good forecasts, predictions of wind fields, also other atmosphere parameters, but wind is the most important. So that's why we have to be connected online all the time with this our very local digital twin. It has to be connected with global databases, and it is possible now, and we take advantage of it. Let's go to the next slide. So what kind of numerical modeling we perform here, and can numerical modeling actually predict the sea? So we are working on it. So first thing, we fit these numerical models with open data from ECMWF. So it's European Center of Modeling European Center, which provides forecasts of atmosphere. So this is one of the most important data set we use. And then we use other tools, and we use these tools like at home. We perform these calculations by ourselves. So what kind of models we use? We use models for predicting waves, and it is from Delft. Also, we use Delft 3D model. Also, we use some models which are developed locally in our institute, because institute performed this analysis from a long time, so it's more than 50 years now. So we have our models which are dedicated to this specific environment of Baltic Sea and our coast. Also, there are specific models for nearshore current, sediment transport. And also we use some models dedicated for prediction of shoreline, coast evolution, for example, X-beach model by Delta RES. So using all these models, we can answer a lot of questions of our stakeholders. What kind of grids we have? So it is important that numerical models always use some numerical grids. So we perform these calculations for specific squares of the sea. And the grid is very important because the size of grid decide about kind of accuracy of calculations. So we perform this modeling for the whole Baltic Sea on using grid to kilometers. But in the very specific area, this is Hell Peninsula map, you can see here. In the very specific area we are interested in, we have this grid of resolution about 100 meters. So it is quite fine resolution, and it allows us to to answer questions we are asked by our stakeholders. So what is important, that simulations only can help if they are accurate. So we have to trust our models, and that's why we test these models all the time, like on a regular basis. As you can see here, it is kind of results of calibration. On the one axis you have results of modeling, and on this x-axis you have real measurements, and after calibration you can see we are quite close. So this is this trust to models. Going to this open data for numerical modeling. So we use this, as I mentioned some minutes before, we use this data from European Center for Medium Range Weather Forecasts, and these are one of the best forecasts which are available now. Thanks to this data, we can have such good accuracy in modeling of the sea. So you can access and download this data freely, which is very important for us, that it is essential for academic operational modeling work that these data are available, and this is a very important thing. So specifically we use wind and also sea level pressure to model waves and circulation. So these data are, as I mentioned, open and accessible via Copernicus Climate Data Store also. So we integrate it daily to our system, and we take advantage of this data. Another data set which we use is from Copernicus Marine Service Ocean Products, and specifically we use this specific data set. It is Baltic Sea wave analysis and forecasts. And why we use this data? So it is mostly benchmark data set for us. And how it works? We have this forecasts provided by Copernicus, but even the best global models struggle with some complexities in the coastal zone, so it is not as detailed as we need. So we need much better resolution, but this is very trusted foundation, and we use it as benchmark to validate our own more localized simulations. So we can make a kind of blending these global scale capabilities with our local innovation we perform for our specific cases. So here we have example of how we exactly use it. So it is kind of first step of calibration of our models. So this upper graph is Copernicus, so it's VAM model. for the whole Baltic Sea, and it is compared to our buoy. So as you can see, that Copernicus model a little bit overestimate this wave height, because here what you can see is wave height, and our model this in this bottom graph a little bit underestimate. So it's our role to calibrate it to make it more accurate. And here you can see before calibration of our model, there is some differences between what is measured and what is modeled. And after calibration, so changing some parameters of models, we have a much more better accuracy here. Okay, let's go to the validation. So during calibration, we changed parameters to be as accurate as possible. But now we on the 5th April we had very great storm, and it was validation of our model. So as you can see, this accuracy is quite good. VAM model from Copernicus and also SWAN model from our set predicted it quite well in 2 locations. So we are quite satisfied and glad because of it that we can trust our models. So let's go to kind of summary. So what is very important when you prepare this kind of tool? So the most important part of this process is working with stakeholders. So our main stakeholders are Maritime Office in Gdynia and Szczecin, and also Ministry of Infrastructure, so these authorities are responsible for coastal protection in Poland. So we work with them, and we ask them for these questions. We can based on these questions, we can prepare these what-if scenarios, and we are trying using all these systems to solve the real problem of our stakeholders. So what we are trying to do. And as summary, I wanted to tell that we are still in the process. It is evolving all the time. So I'm very happy that I can attend this process of building this completely new technology for our coast. And stakeholder engagement is the most important. And also we try to integrate some AI solutions to improve this accuracy. So thank you very much for your attention, and I hope it's interesting to you. That's it. Thank you.
Thank you very much, Alexandra and Pascal, for the great presentations and very insightful examples on what can be done with marine data. It's always very nice to see about these pilots of these projects on how to leverage from current projects that we have, current initiatives of data sharing, and to see actually what's the added value from doing that. So thank you so much. So I think we can start with the Q&A session. Yeah, Pascal, you have your on. So I think we can get started with Pascal because there were a couple of questions. And then please, if you have any question for Alexandra, feel free to drop it in the chat, and I will they will be addressed at the end. So we had a first question, Pascal. It was very impressive to see the data analyst tool and what can be done. So the first question was, who is the people behind it? How many people are working behind this platform?
One. Only one. And it's also why I invited our people to read the press review. So basically, the original idea came during hackathon in Tallinn few years ago. And thanks to COVID time, I had the time to code for 3 months, days and nights, the marine analyst. So basically, now that the platform is fully operational, you need one guy or woman to maintain the system. but it has a lot of processes to check for the errors, to add new data sets. So one person is needed to maintain the platform. So it's a really interesting question. At some point, I wanted to have the platform fully autonomous. So nobody caring about the system, like full integrated code. You read the Inspire services. You go through the metadata, you discover the capabilities, you set up the scripts, and that's it.
So I understand currently, and this is linked to another questions that how do you update these data sets? What is the most up-to-date data set that you have on this platform?
Uh, it depends. Let's take the example of ImmonNet. If a data set is updated, most of the time the new report that will be generated will have this update. But it depends. Time to time, you can have also timestamps, and you have to go through the scripts to change the timestamps. Not everything is automated, but it could be possible, basically.
Okay, I understand. And what is the scope of the data sets? Uh, I understand that it's European region, or is it wider?
Uh, so the original idea was really to consume and to operate as a metadata broker for ImmonNet and Marine Copernicus. So the original idea was to have a focus on Europe, but basically, well, not only we have been contacted, for instance, some years ago by NOAA, which was quite impressed. So if I remember, it was a director of NOAA contacting us because of our marine protected area tools. And so we could, yes, invest a bit more and get more data for the global globe. For instance, we have the JEPCO dataset, the bathymetry, which is global.
Mm-hmm.
But the original idea was really to consume Marine Copernicus data and ImmonNet. The difference between two initiatives is that for Marine Copernicus, we've got global datasets, while for ImmonNet, it has a focus on Europe.
I see. I'm actually, this is being linked also to another comment on how we could leverage actually from the marine analyst, because we are aware about we have also all these commission services. You were mentioning also EVOTnet. How do you say this tool applied or combined with these services? How what can come next? How do you
So
think it can be it can add added value?
What I will say, what is obvious if you go to the example that I've provided on the MPAs, the marine protected areas, and there is this week a conference on the ocean. It's the idea is to protect our seas, and you see with this example, for instance, you can by using the data from ImmonNet on the vessel traffic to see if MPA is really protected or not. You can collect this information. So the idea of Marine Analyst is basically to take the data and to produce knowledge, something you can read and you can understand. And here in the example of this report on vessel densities, you see the trends, you see what are the activities within the marine protected area for real. So
Mm-hmm.
I've seen some NGOs working on this, trying to collect the data and to process the data in order to produce a report. Here, you as a citizen, you can produce this, and you can see if there are no fishing activities within a selected MPA. So you can understand this aspect. But more than this, what I see with a marine analyst is the trends in accessing data. I will say the philosophy I've seen since since we have these Gen AI agents, that the access to data has changed a lot. And here I can give you an example, something that is really difficult for, I will say, the European Commission, for instance, is to collect socio-economic data at the coast. Because you are in a silo vision, so trying to I will run a program where I will collect this data on socioeconomic information on the coast. The problem is that the data is fully disseminated and unstructured. You can put instruments to measure the waves, the temperature at the coast, but something you can't do is to collect this unstructured data from the human activities at the coast. And the Gen AI is very good at this. So basically, what you discover is you can get this data from Gen AI agent. And what we've got discovered is that the marine analyst is really contributing to this global knowledge.
Yes, indeed, indeed. And actually, yes, generative AI is also a topic that is being used in different broad topics. And okay, now I would like to move to Alexandra, because actually there was one question on artificial intelligence and creating artificial intelligence based weather models. With your project, there was a very impressive project on this pilot project. Are you currently investing on these cutting edge technologies on artificial intelligence? How far are you? In which step you are on the process? What are the plans for the future?
So yeah, we do test. it would be strange if we don't. So we do test these tools. So what we did, we tried to make forecasts, to develop forecasts for wave height. So of course we use like classical physics-based modeling to predict significant wave height or other wave parameters on the sea. But also we wanted to check if it is possible to predict only using data without any physics in it, in this modeling. So we tested variety of methods, some of them like typical statistical methods only, like prediction of time series, so it is nothing new. But also we used these artificial networks, and it occurred that LSTM networks are the best in these cases, and we were able to make these predictions which are of good accuracy for 6 hours. So because normally using these physics-based models, we have predictions about 50 hours, but also it is because we use very good input from wind, which we don't model atmosphere, so we use these external data sets for wind. So if we have good wind, we can calculate good waves with good accuracy, but using only this database approach, we produced this forecast for 6 hours. We have a paper. Well, I think that in this paper, it is published. It is from this year, from ocean engineering. So if you are interested, I can put this later on in the comments in YouTube, or I don't know where. Also, you can find this paper using my name. So we described very in details the methodology we used, what kind of test we performed, because it is our stage as for now. So we are the tests are finished. We know which methods are useful and which are not. And now we want to apply it to the system. Just this tested algorithm, it's ready to be applied. So we are in this moment of development of these new methods.
Perfect. Thank you very much, Alexandra. I think that you can indeed share also with us this link that you are mentioning, and then we can also include it in the recap email
Yeah.
to ensure that all the
Okay.
participants have this information. There was a question also, Alexandra, on the calculations.
Mhm.
So the question was on how do you do this calculation? Like one of our attendees saw that you were using the logo of Jupyter. Are you using Python in order to make this calculation, or what is the process behind it?
We, in fact, we don't. So, of course, we use also Python. So, as I showed you on one of our slides, we use a lot of tools, and some of these tools are developed by other institutions, like, for example, Deltares from Holland. So these are like closed tools. It's software, but also we use our own developed models, and we use variety of programming languages. I believe that some of them are written in MATLAB. Uh, we also use Fortran. We also use Python in some of this. It depends of the part of the system, because the system is quite complex of all these models, and we use different tools for different purposes. So there is no one answer. Python is also used, but not only Python.
I see. I see. Thank you so much. And last but not least, just one question for you both. So we were addressing here a lot of data and harmonization, calibration of the data sets. But the question from one of the participants is like, how do you bring all these different data sets together? Do you implement it with a kind of software system or a platform that generate new information from all these input data? Or how do you do that? Alexander, if you want, we can start with you and then we
Yes.
can go to Pascal.
So we
And then
can,
we'll close.
to integrate all data, we have distributed IT system. So it is, I think that several computers which are connected. So some of computers are located in the field, close the measurement stations, and this data are sent to our central computers, and all of these data are processed. And this information system is developed here in our institute during this project. So we have one system is integrates all data from the field. Another system we perform all calculations, so for numerical modeling, and also we have another system which is very important to keep everything working, because we have to monitor these devices in the field all the time. If we have contact with them, if they are in good shape, if batteries are okay. So we have another system to monitor and to keep eye on our measurements. So
Okay.
that's it.
Thank you so much. And Pascal, from your side?
Interoperability is key. Here I can say that I've seen the question. So it's about promoting DCAT. It's a RDF vocabulary. So meaning having information or data which is machine readable and actionable. And if we go at the level of metadata, we've got DCAT AP. Promoted by CEMIC, Digit, the European Commission, the Publications Office. And for data, for instance, when it is about tabular data, we should recognize that, for instance, CSVW, the tabular data on the web, is a standard which helps in disseminating interoperable data. So basically what I want to say, if you have a data, you must be sure that the data is well structured using a standard, so that a human can read it, but also a machine. We all recognize that nowadays we need tools, AI, to process the data. We've got a lot of data. We have to do this effort of standardizing our data. So CSV, for instance, is very popular, so machine can really read it, but it is missing the semantic aspect. And with CSVW, for instance, you can annotate your data so that a machine and also human can understand the data. We are all going through this direction.
I see. Thank you so much, Pascal. And again, Alexandra, for the wonderful presentations and also all the insights. The good thing is that there are like many opportunities also to follow up. I saw also in the chat that there could be some potential discussion or collaboration. I really encourage you to follow up on that also. Collaboration channel in place where you can start also the discussions and to follow up on what you thought about this webinar. It's very important for us that you join our collaboration channel. There's one for data reusers where you can directly join and comment and discuss what you thought about the webinar, what you think about marine data, about the tools, and of course we will make you reach out to the right person. So your opinion is also very important for us. So please take a few moments to fill in our survey. And now we're heading to the weekend. So I hope you have a wonderful time, that you will also enjoy this webinar. And a special thanks to Pascal and Alexandra for make this happen. Thank you so much for all the insights.
Thank you all. Thank you, Inma.
Thank you so much.
Thank you for invitation and have a nice weekend. Bye bye.
Bye-bye.
Bye bye.